Hi, welcome to the demo on C# control statements. Now in the first part of this demo, we'll take a look at the two most common decision statements that C# makes available for us. We'll look at the if statement and the different ways that we can work with the if statement that we have available in C#, and then we'll take a look at the switch statement, which is another way of making decisions within your application. So in the first part, we'll focus on decisions. The second part, we'll step into looking at some of the looping structures available. Now in this demo, I've created three variables here at the top, which will be used throughout our decision structures, and they're just conditions that we're basically going to check on the value as we look at each one of our if statements or if-else samples, or the switch, and we'll use those to make decisions within the code. Each one of them is just set up as a simple integer for the time being. It makes it easy for us to do the comparison, but note that these conditions can be string values or other data types as well. So in our first statement, we'll take a look at a standard if sample, and this is just a really quick and simple if statement within C#. Here we do an assignment of condition 1, and we give it a value, a numeric value of 1. And within our if statement, we check to see if the condition 1 is equal to 1, and if so, we will output a statement to the console that says the comparison evaluated to true. And also note that I've added an extra line here that says this executes after the if regardless of what has taken place. Now, it's important to note that within C# we have the ability to create an if statement that looks something like this. So what I've done is I've essentially removed the curly braces of the if statement itself. And this is perfectly legal in C# as long as you are only going to execute one statement. It works perfectly fine. It has a tendency to create confusion if you don't put the curly braces in, and the reason being is because some folks will focus on tabs. So if we had this line tabbed in to the same tab stop as the top line, sometimes there may be confusion as to whether the second line will execute or not. As a matter of fact, there are some programming languages out there that use decision structures that focus on the indentation as opposed to anything else for which statement will execute. But if we put our curly braces back in, regardless of whether we're actually using only one statement within our C# block or not, then there is no confusion as to which line will actually execute within our C# statement. So my coding conventions is a preference to use the actual curly braces. Then there is no confusion as to which executes. So in this first if statement, if we do a control F5, we'll see that the output says comparison evaluated to true, and of course our other line, this executes after the if regardless of the condition. So again, a very simple if statement. Now let's go ahead and comment this out so that we can work with our next example, which gives us an if-else sample. So what we're attempting to do here is say that we may have a potential alternative condition. In other words, we're checking to see if a value is true. If it is, we'll output one statement. If it is not true, we'll output a different statement. So this is the else clause. So we're setting condition 1 to 3. We're going to check to see if it is equal to 1, which we know it's not. So therefore our else clause should be the one that executes. Quick run of the code, comparison evaluated to false, and that is exactly what we should have expected to happen. We can continue to add multiple ifs and else ifs for really as much as we actually need to put within our code, but it can get kind of cumbersome and really difficult to read after a while. If we take a look at this particular example here, it's not overly complex, but it does have an if condition, an else if condition, and an else condition. And in this case, we've set up a few different variables, and we're setting up condition 1 and condition 2 and assigning them values. We're going to check to see if condition 1 is equal to 1, and if it is, output this statement. Else, if condition 2 is equal to 2, we'll output this statement. And if neither one of those evaluates to true, we'll output this statement here. So let's go ahead and execute this, see what happens in our code, and we simply say that condition 1 is true. So essentially what happened was we did our first check, found out that condition 1 was equal to 1, and we went ahead and wrote out this particular instance. Now you might be looking at it and saying, yes, but condition 2 is also assigned to 2, so why didn't the else if execute? And simply being the fact that the first condition was true, we executed that statement, and then we essentially C# broke out of the code. If we went ahead and set this to a value of 3 and execute the code again, in this case we'll say condition 2 is true. So what happened there was condition 1 evaluated to false. Now our decision falls through to the second condition check, which is the else if, to see if condition 2 equals 2. Now we can also change this condition so that it will also evaluate to false, and we should fall through to this statement here. And in which case we do, it says neither condition is true, and that's exactly how we should have expected it to work. Now, as we step through all of this little bits and pieces of code, you can start to see that these if and else if statements can grow quite large. We can have multiple else ifs and else ifs and else ifs all the way through for many, many different conditions. But it can start to become very confusing and hard to read in the long run. So C# provides us with another decision structure, which is the switch structure. And this essentially allows us to go through the process of multiple conditions to test, but in a much cleaner way. And what we're doing with the switch statement is we're setting up a condition, and in this case we're calling it switch condition, and we're assigning it a value 3. And then within the switch statement we start checking for that input value, and then the case statements are the ones that are responsible for testing which one it is that we have assigned to that value, outputting the appropriate value based on what that input value is for switch condition, and then breaking out of the actual switch statement itself. So if we look at our condition variable is set to 3, so if we execute this we should actually output value is 3. So control F5, value is 3, and indeed it did actually execute what we want it to. Again, as the course probably pointed out to you, there's a default case which is available here, in which case it will execute if none of the conditions match. So if we were to set our variable to 5 and we were to execute this code again, the value is 5 and it output that because of the default case, which we said console.writeLine value is in whatever the switch condition that was passed in. Note that each one of them must have the break condition or the break statement so that we break out of it appropriately and it doesn't fall through to the next switch statement. Alright, so that is a very quick demo of the decision control structures that we have available within the C# programming language. Now let's go ahead and take a look at what we have available for our repetition statements. So I'm just going to close out my region here so we can clean up our code a little bit easier. We only have to deal with what we want to see on screen. So here's our repetition statements, and we've got a for loop, a while loop, and a do loop, and then we'll talk a little bit about recursion. So let's look at the for loop first. In this case, once again we will uncomment our code, and we have a for loop. We've got a couple of counters here that will come into play for the while loop and the do loop. In the for loop, we're just simply going to write out that we're actually in the for loop, put a blank line in, and then in the for loop we have our initialization component, we have our condition check, and then we have our iteration, which will allow our counter to increment so that we will eventually end, so we don't want to create an endless loop. And then we'll just simply output what the values are. Now in this case we're saying for counter starts at 0, and as long as it's less than 10, let's go ahead and output some values. In this case we say that the for counter is set at 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And it shouldn't be a surprise to you that we stopped at 9 and not 10, because we started counting at 0 and we said as long as it is less than 10, we simply could use this comparison operator that says if it's less than or equal to 10, we'll continue to execute, and then we would output 10, right? So the counter would continue up to that value, all right? So that's your demo of a simple for loop. Let's go ahead and take a look at a similar concept. In this case, we'll use the while loop. Let's comment that out. So now in the while loop sample, we are going to take a look at executing some code while a condition or a counter is at a specific value. Now in this case we'll just simply do a couple more console write lines to say what kind of a loop we're in. And the while loop says while the while counter is less than 5, and we know that up here we've set our while counter equal to 0. So we'll say while it's less than 5, let's output this line. with the value of that counter, and let's increment it. Again, when you're doing your while loops, do not forget your incrementation portion, otherwise your loop will continue and won't end itself. So let's go ahead and execute this with a Control F5. Again, our while counter prints out 0, 1, 2, 3, 4, 5. No surprise there. Again, because we said less than 5, so while the counter is less than 5, we'll execute that while loop. Now, as we mentioned in the course itself, in the course content, the while loop and the do while loop are slightly different, and sometimes programmers get a little confused over the difference between the two, and a lot of the times if you're taking exams or tests, they'll ask you what the difference is between the two loops. And it's important to note that the do loop will execute the content of the loop at least once, because the condition check doesn't happen until the end of the loop itself. So as it sits right now, we've set our do counter equal to 0, so it should execute the same as our previous while loop. Let's do a Control F5, and we see that do counter is at 0, 1, 2, 3, and 4. So that looks exactly the same as our while loop. Doesn't seem like there's any difference in here at all. But what happens if we come back up and set our do counter equal to 5? So our condition check is looking for less than 5. In this case, we're setting it to 5. The while loop would never have executed in this case, but our do loop, if we execute it, will. And it tells us that the do counter is at 5. So again, that's your main difference between a while and a do while loop. We will execute the contents in here first, and then we will check the condition afterwards. So your do loop always executes at least once, regardless of what your condition is actually set for. All right, so the last piece that we need to focus on for our repetition is a recursion sample. And now in a recursion sample, this one here we've actually set up to use the standard factorial type of recursion. So again, our factorial is just simply a mathematical function that allows us to take a look at multiplying the number times the previous number continuously, and it will come to an end because we have to set up some kind of a control for the factorial. And essentially what that control is once we reach the value of 0. So if we start off and our end value that we're passing in is 0, we'll just simply return 1 and say that we're done. Otherwise, what we will do is return another call to the factorial function itself. And in this case, we'll take n and we'll continue to decrement it by 1 until we reach the input of n being 0. So if we execute this and we generate an error, we have to come back and debug and find out what it was that we did wrong. So we're expecting a curly brace in here at some point, which means that I have uncommented something out incorrectly somewhere along the way. And we have, because this is sitting inside the main method, and give me 1 second here. I think I have too many curly braces, which makes it a little complicated to see where we're at. Is it happy with that one? No, it is not. So I'm still expecting a curly brace, and this usually happens when we set up all of these different functions. So what I'm going to do is I'm actually going to take this function, just briefly move it out of the main function and paste it down here. So we'll still call the function, it's just that it's not sitting within that other function itself. Now we should be able to execute this perfectly fine. And so we have run recursion, and you can see that we have actually returned a value of 3,628,800. How we arrived at that number was the fact that we passed in 10 as the argument, if you will, to the parameters of factorial. So that meant that we basically started off at 10, multiplied 10 by 9, and then 9 by 8, and 8 by 7, etc., all the way down until we got to the 0, and then we returned the total value. And remember, one of the things to try to stay away from in recursion is don't sit here and try to think of how this function is going to return values itself. You just break it down into its simplest, and knowing that we're looking for the end state, which is as long as that factorial equals 0, we have completed, and then the value will return itself. If you want to take a look at how it functions, you can go ahead when we start talking about debugging and setting breakpoints. You can come back to this demo, or you can write your own code, set a breakpoint, and then step through the code one line at a time, and you can see where the values end up being placed. But again, that's for another time, and this is just, again, the quick demo on the control statements that we have in C#.